Selamat pagi Bapak Ibu Guru dari jenjang SMP dan SMA. Senang sekali bisa bertemu kembali dalam satu lagi kegiatan yang begitu positif yang diselenggarakan oleh sekolah kita, sekolah Pahoa, untuk menjadi sarana pembelajaran bagi kita semua. Ya baik Bapak Ibu, senang sekali untuk berjumpa lagi dengan Bapak Ibu. Hari ini kita mau belajar bersama topik yang cukup menarik dengan judul atau tema Sinergi Six Elements of Teaching dan STEAM. Sebagaimana Bapak Ibu ketahui bahwa di Pahoa kita sudah menjalankan atau mengimplementasikan Six Elements of Teaching by Dr. Yeap, dan sekarang kita akan mengintegrasikannya dengan STEAM ya Bapak Ibu. Kita berharap dengan pembelajaran di hari ini, STEAM nantinya bukan hanya menjadi satu pendekatan pembelajaran yang sekedar dipraktekkan di kelas, tetapi dapat juga menjadi salah satu jalan untuk membuka cara berpikir siswa kita untuk bisa berkreasi, berkolaborasi, dan memecahkan masalah secara nyata. Baik Bapak Ibu, sesi pertama akan berlangsung dari pukul 8 sampai 9.30. Tidak berlama-lama lagi, kita sambut, mari kita beri tepuk tangan untuk pembicara kita, Dr. Yeap.
Good morning everyone, selamat pagi. My name is Banha and I'm happy to be back to do today's session with you. So as you have heard, the first session is from now until 10:30, and then we have a break. And after the break, we have a short session where you're going to be having a little bit of chance to talk to people teaching other subjects. And then we have a closing. Right, so that's our agenda. The first session is for me to share with you some things connected to today's topic. So, today's meeting, the main purpose is for us to widen, to increase our repertoire of teaching tools, is to give us more ways to help students learn. So you probably know that in Pahoa School, just like many good schools around the world, increasingly we are moving away from teaching to focus on learning. So everyone knows that nobody cares what we teach, but everyone cares what their children learn. Right? So learning is increasingly becoming the focus of our job. I mean, the word teacher is of course an ancient word. It's a word coined a long time ago. It's a word that was invented a long time ago when ancient teachers like Socrates, they don't have internet. Even books were quite rare. So the word teacher was created at a time where facts and information was valuable because people do not have access to facts and information. But you know, today, it's a very different story altogether. In fact, some people say you don't even need a teacher anymore because you can learn almost anything by watching a YouTube. Yeah? So really, the purpose of today's meeting, the goal of today's meeting is to add to our toolbox of a teacher how to make students learn. Yeah, so that's the main purpose of today's meeting. We already know about 6 elements in the learning experience, the 6 experiences students need to have when they learn something. And many of us also know a little bit about STEM or STEAM. Right? So that's generally what we'll be looking at today. Right? So we are going to start by asking you to just talk to each other. You can check on the internet as well. Just tell each other what you already know about STEAM education. What is STEAM education? All right? 2 minutes. Turn and talk to people around you. What is STEAM education? Yeah, silakan. Sorry to interrupt you. So, what did you learn from your friends? What is STEAM education? If you can give me some words, some phrases, you can just say loudly from where you are. Maybe one response from this section. So, what is STEAM education? I'm sorry. Combination learning. Yeah. So, learning across subjects. Yeah. So, one element of STEAM education is when students are learning across disciplines, across subjects. Integrated learning, interdisciplinary learning. I think there are many words to say the same thing. Is that what you meant? Yeah. So, one aspect of STEAM education is that whenever students learn whatever they learn, they can see the relevance in mathematics, in history, in art, in science. At least 2 domains will come into being. Maybe someone from this section? What is STEAM education? Something else you told your friends a while ago? What is STEAM education? Yes, please.
Collaborative learning, interdiscipline about science, mathematics, art, technique, and engineering.
Yeah. So you hear the different domains mentioned in the acronym STEAM. So STEAM is an acronym. So the STEAM stand for the different disciplines, yeah, that your colleague, your friend has mentioned to you. Yeah. So STEAM education often include quite a lot of sciences, mathematics, and the application of sciences and mathematics like engineering, technology. But then there's also the elements of the arts and reading, isn't it? Yeah? You also hear something new from this sharing. What's the new thing that they were saying that was not mentioned by the first group? Collaborative learning. So very often in STEAM education, students are not working by themselves, but they are working together. So we all know that grades are just grades. Grades you get in school at some point in your life will become not important. It may be important at some point in time, but in the long run, it is obviously not very important. But how a young person talk to other people, how a young person respond to another friend, how they interact with people, how well they can communicate with colleagues, how kind they are to their friends will eventually become the most important thing that they get from their education. Whether it's education from home, their parents, how the parents taught them when they were younger, and what the school and their teachers helped them learn when they were in school. So obviously, working with other people is important in developing not just skills, but also values. Yeah, so that's quite important, collaboration. Yeah, so we heard about collaboration, we heard about the interdisciplinary characteristic of STEAM education. Maybe one more, something else that this group have? Yes, please. Real world connection. Yeah, so hopefully, whatever they do have some real world connection. Yeah, some real world application or just connection. It may not be application even, although some people say you need to be solving a problem. Yeah, but I suppose a real world connection is important. Whether the connection is functional or just aesthetic. Functional means it has a use. Example, maybe students are doing a project to help their grandparents be able to move around the home in a more safe way. So it's functional. It has an actual use in practical sense. But it may not be functional. It could be aesthetics. just make your life nicer to live in. Just make you happier. That's, I suppose, also important, although some people may not say that's functional. It's not that important, but it's nice to have. Yeah, example, building designs or people who create art. I mean, I think it's important, but it may not be something that is a matter of life and death. Yeah, to have nice buildings. Well, the building is just to put a roof above your head, but it's quite nice if the buildings in a city are all nice to look at, because then it will attract more people who want to live in that city. You will attract more investors wanting to set up companies in that city, and hence give more jobs to local people in that city and improve the economy of that city. So initially we may not think of it as really important. Oh, museum. It's quite nice to go to a museum and look at nice pieces of art, but well, does it have any use? Maybe it does. When a city has many museums, again, the quality of life improves, and that always attracts talents. When there are more talents in that country, then obviously the economy will concurrently improve because it will attract foreign investment. So anyway, yep, real world connection. So I just want to broaden the notion of real world. While many of us may think of real world connection as something functional, like creating something that's immediately useful, but maybe even things that may not be immediately obviously useful can eventually be quite important. So many of us know that in many disciplines, example in mathematics, some people will do mathematics that don't seem to have any real world application at that point in time. But 200 years later, someone will use the same mathematics to make sure your credit card is safe to use. But when someone created the mathematics long time ago, it was just for fun. There was no immediately use for that particular piece of mathematics. But long time afterwards, nowadays you use your credit card without worrying too much, thanks to that part of mathematics that was created just for fun. Mathematicians call that recreational mathematics. It's just for fun. It's just for recreation. It's almost like just a puzzle, just a game, just something nice to think about. But who knows? At some point in the future, it may be of great use. Yeah? Real world connection. Maybe this group can offer us what? Yes, please. Problem solving. Yeah? So sometimes we think that STEAM education is for students to solve a problem. Yeah? They will apply what some people call design thinking. Design thinking in solving a problem. Oh, what is design thinking? Some of you are asking. Talk to each other if you know what design thinking is. If not, you have information in your hand, literally. Design thinking. 2 minutes. Tell each other what is design thinking. Yeah, what is design thinking? Because problem solving often involves design thinking. What is design thinking? So what is design thinking? So thanks to 4 groups, we now know what is STEAM education. So when Pahoa school say, oh, parents, come to our school, because our school, we do STEAM education. And then parents ask you, oh, what is STEAM education? And you say, oh, in our school, we let students engage in problem solving. And our students learn about design thinking. What else did we talk about? I forgot. I remember there were 4 points, but I only remembered the last point, which is problem solving. What were some other points that were brought up by our friends? Okay, what else? So what else? Yeah, so I remembered someone talk about interdisciplinary, involving different subjects. The subjects are the S, T, E, A, and M. Yeah, so the A include arts and reading, languages. Yeah, and then we talk about collaboration. Yeah, and then what did I miss out? Other than interdisciplinary collaboration, problem solving, I think I missed out something from this group. The real world connection. Yeah, the real world connection. So you can tell parents, oh, that's what we do. Yeah, these are some of the things that your child will be experiencing when they come to Pahoa school. Anyway, what do you find out about design thinking? So some of you may know about design thinking before today, but some of you may not know what it is yet. It's fine. We learn together all the time. So design thinking, what is it? Anyone would like to share with us a bit of what you know about design thinking? What is involved in design thinking? Anyone? Yes, please.
As far as I know, it is creative process to complex problem,
Yeah.
which is human-centric.
Yeah. So you want to solve a problem that is connected to some human activity. Yeah. And hopefully it's creative. So you can come up with a product that is different to what many people have invented before. So it improves quality of life perhaps because you just created something that never existed before. So for example, when someone created the internet, it made your life so much easier. Before you need to look for a telephone, if you want to call your parents, your family from America to Indonesia, and got to pay a lot of money making that call. Okay, some of you are so young, you never experienced that before ever, because you always have the free WhatsApp that you can make a video call practically for free. If all you need is your cell phone and Wi-Fi or some connection, isn't it? So design thinking. Someone else would like to add to that. What else do you find out about design thinking? Yes, please. Yeah.
It's a way to solve problems creatively, and it helps. It starts with understanding people's need, and then think of ideas, then make something, and after that we improve it.
So you have some stages. It starts with understanding what the user need. Yeah? And in English language, I think the word sometimes they use. Anyone know an English language word for like put yourself in someone else's shoe? Oh, empathizing. So empathize, to empathize, empathy, which I think is a value you teach in this school. I'm quite sure because you focus quite a lot on values. Yeah, and being able to empathize is quite important. And once you are able to empathize, you define the problem. So after empathizing, you move on to defining. Yeah, you empathize first, then you define the problem. Because without defining the problem, we have no problem to solve. So our students in a traditional education are always given the problem. Here's a problem, you solve it. It's almost treating them like machines. Maybe it was sufficient 50 years ago. Maybe it was okay 30 years ago. But these days, being able to formulate, being able to define a problem, it's probably more important than being able to solve it. Because we got so many ways, so many non-human applications that can solve problems in no time at all. But we still need, hopefully, we still need humans to be able to formulate, to define the problem. I mean, not just in school, not just in workplace, but I think also in our personal life. Why some people seem to be always having problems in their lives and others just sail through their lives smoothly. So it depends on how good we are in formulating problems. So people who seem to have no real problems in their life is because they are very good in identifying the problem. And once you identify the problem, it is practically solved. I think someone once said that. Anyone happens to know? A famous quote that says that the problem is way more important than the solution. Some of you might know that. So once you are able to empathize, that's the first stage in design thinking. The second stage is to define the problem. And once you define the problem, no, you don't solve it immediately. You want to brainstorm. You want to get good ideas. Because you do not want to jump into the first thing. You do not want to get one solution and be happy with it, because you might miss out on better solution, more optimal solution. So you do not want to jump into solving it immediately. You want to brainstorm. You want to get more ideas. You want to ideate. Yeah? So after, what was the first step? I forgot. Empathize. Second step, to define. And then now you ideate. To ideate means to generate ideas, to come up with a lot of ideas. Some people call that brainstorming. And once you get a lot of ideas, can you now tell your friends what are the last 2 steps in design thinking? 1 minute, tell each other the 5 steps in design thinking. Right? Do you tell your friends the 5 steps in design thinking? After empathize, you define. After you define, you ideate. After you ideate, so you prototype. Yeah? You make the thing, whatever it is. Not go to factory and make 1 million copies of it, but just 1 or 2 prototypes. And then, of course, you need to test it to make sure it's work. And once that's done, it's done already. Then now the factory, the machine, the automation will generate thousands, tens of thousands, maybe million copies of the same thing, which is not even in the process, because that's mechanical already. And this is the human bit. This is the important part. Yeah? So in STEAM education, some people talk about design thinking as well. Now, for today's session, we just want to introduce you to this, if this is something not familiar, but some of you already know about this. Now, our purpose is to think of more ways to help students learn. That's our big purpose today. More ways to help students learn. Going beyond our comfort zone of giving lectures. Yeah? Of telling students what to do. Of always explaining to them. So moving away more from teaching to learning. And this is just one of the many ways to make learning more interesting. So before we go into one activity to get us thinking more about ways to make our lessons helpful in learning, maybe I will now just summarize something that all of us know already. Why are they in school? What is the main purpose when they are with you at SMP and later at SMA? But let's start from the very beginning. Yeah? At home or preschool? What are they supposed to learn? They are supposed to learn languages. That's what parents do. They talk with a child. They talk with each other to model language. And later when they come to kindergarten, the teachers continue to talk with the child, to talk with each other, to model language. And that's how everyone learn language or languages. And at Pahoa, the children are really fortunate because they are exposed to 3 languages, which also help the brain develop in a way that is way better if they were exposed to merely 1 language. So the research is basically, when you speak to a young child, use your best language. So if the mother is very good with Indonesian language, use Bahasa Indonesia. If the father is very good with the Javanese dialect, speak Javanese. If my English is not very good, I will not try to use English with a newborn baby. I will just use whatever language that is native to me. So that is the research. So that not involve us professionally, but some of you may be parents to young children. Yeah? Some parents have this misconception. Oh, English is very important. I want my child to learn English. And they try to speak only English with the child, even though their English is not their strongest language. And they neglect to speak to the child in their home language. Yeah, but for us teaching SMP, SMA, this is not connected to us professionally, but maybe personally for some of you. Anyway, a young child learns two things before they go to S-Day. So whether at home or kindergarten, languages and social skills. Those are the most important things they learn. It's broad-based exposure to how people talk and how people interact with each other. So parents at home are polite to each other. Parents at home are kind to other people because they want their children to learn to be polite, learn to be kind. And when they go to kindergarten, their kindergarten teachers are polite with each other, are polite with the children, are kind to each other, are kind to the children, because kindergarten teachers want the children to learn to be polite and learn to be kind. So languages and social skills. And then they go to S-Day. The purpose of S-Day, obviously, is continue languages, social skills. And then the third thing is added in. Exposure to mathematics. And a little bit of sciences. And a little bit of social studies, the humanities. But it's really an exposure, an introduction. And now they come to you in SMP. So in SMP, maybe even up to grade 10, the purpose is to give the students a big offering of what is possible. It's like you going to a buffet or buffet. So much food this morning when I went to the breakfast table in the hotel. There's Indonesian, there is Chinese, there's Western style kind of breakfast. It just shows you what is possible for you to eat in the morning. Likewise, in SMP, our job is to expose students. Like, here, try this. If I'm a history teacher, maybe you might like it. Maybe you don't like it. Doesn't matter. But try this. The Chinese language, the Mandarin language. Maybe you like it, maybe you don't. Or try this. Mathematics. Maybe it's something you will like, that you will do for the rest of your life. Or maybe not. It doesn't matter. We cannot make everyone like the same thing. You cannot make everyone like bakso. It's impossible. Also not good. Then there'll be a shortage of bakso in the world if everyone likes the same dish, isn't it? So it's normal that some people don't like history. It's normal. Some people don't get excited about mathematics. It's normal. Don't take it personally if you're teaching that subject. Hopefully, they will like it because you have portrayed the subject in such an interesting way that those children become attracted to it. But it doesn't matter if they don't like it, as long as they gain some skills through it. So even though I may not like mathematics, but if I can benefit by participating in mathematics lesson 4 hours a week, 8 hours a week, then it doesn't matter that I do not like mathematics, because by going through mathematics for 6 more years in SMR, SMP, I learn to think. I learn to collaborate. I learn to solve problems. I learn to communicate. So if mathematics lesson allow me to learn all the important things for me, even though I'm not an engineer in the future or mathematician, even though I become a lawyer, But through mathematics, I've learned how to present ideas clearly. That's important to me professionally as a lawyer. Yep, so our job at SMP up to grade 10, first year of SMR, is to offer that buffet. Like, these are all the possibilities. And the students learn a little bit of it, a little bit of that. So that is what we do in the first 4 years of secondary school. Give them the possibilities. And then in the last 2 years, very important, they must pick some things they quite like. And they begin to study that in depth. So the critical bit of grade 11 and grade 12 is to go deep into a subject. And some things you no longer pay attention to it. For example, in Singapore, in grade 11 and grade 12, the students will pick 3 or 4 subjects that they want to go deeply into. Oh, this is beyond languages. So they all, of course, continue to learn English for communication, English for thinking, English for writing. So they will learn this subject that we call general paper. It's actually English, where you learn to read, where you learn to write around issues that are important globally or locally, which cover politics, history, mathematics, sciences, the different domains. So in general paper, English, they learn to understand the world, a little bit of this, a little bit of that, philosophy, mathematics, engineering, geography, history. So at the end of learning it, when they take the examination, they have to pick one topic and write an essay on it. And the topics, maybe 12 of them. Of the 12, one may be based on sciences and mathematics, one may be based on geography, one may be based on ethics, different domains. And then they pick one and they write about it. And then they also have to answer some reading comprehension question. They may be given 1 or sometimes 2 similar articles to read from authentic sources, and afterwards they answer some questions and even write a summary. So, of course, they continue to learn English because that's the language they use to learn all the other subjects. And then they are also supposed to continue to learn their home language. Not at a very high level, but just at a level where you're expected to learn. But some of them have taken home language at a very high level in grade 10. So for those who have taken home language at a very high level in grade 10, when they go to grade 11 and 12, they can say goodbye to the home language, at least in school. But at home, of course, they continue to use their home language, or outside when they go and buy things, talking to the auntie who sell them the char kway teow, they continue to use their home language. But in school, they no longer need to spend 4 hours a week learning the home language because they have learned it enough already up to grade 10. So, a grade 11 and grade 12 student in Singapore, they will of course learn English and home language. And of course, they will do physical education because everyone needs to exercise. Once a week maybe. And they probably have some lessons on things connected to morals or values. But not just lessons in a class. It might be activities, but basically opportunities to continue, to be reminded, and to continue to improve their skills in interacting with other people, and also hopefully consolidating the values that they have. And quite importantly, they have sessions on career counseling, because this is probably the point where they are thinking about which subjects they're going to study at university. So other than those maybe 10 hours a week, 12 hours a week on languages and smaller subjects that has no examination like PE, career counseling, values, whatever we call them, a bunch of things. They focus most of their time on the 4 subjects or the 3 subjects. So some people may pick mathematics, biology, chemistry. Some people may pick economics, history, geography. So they'll pick whatever and they go quite deep into it. So what do the teachers do when they are given 8 hours a week, 7 hours a week to teach history? You cannot be lecturing at them for 7 hours, meaning you see them every day. If you get 7 hours a week, because in a week there's only 5 days. So some days you see them for like double. What are you going to do with the 2 hours? You cannot be lecturing at them, obviously. Yeah? So I suspect Pahoa is moving towards that direction as well. To be consistent with the best education that's offered around the world. So the best education systems, the best schools around the world always have this characteristic. They prepare their students in that way. In preschool, languages, social skills, values. In primary school, SD, exposure to mathematics and sciences and social studies. SMP, exposure to many subjects. And then at SMA, they become quite specialized. So certain things are no longer important, they will leave them behind. And they begin to focus on something that will prepare them well towards university. But when you have 8 hours a week, what are you going to do with them? You cannot be lecturing at them all the time. And today's session is part of that. What else can we do with them? All right? 2 minutes for you to just talk to people around you, something that you hear that is, oh, that's interesting. And then we'll begin our first activity. So 2 minutes just for you to not to have to listen to me. When the paper comes to you, take a few pieces each. Work with your friends so you don't need, yeah, just a few pieces each is fine. Yeah, 2 or 3 pieces for the next activity. You'll be working with people around you, so it's collaborative. All right, sorry to interrupt you, so let's continue to the next part. The next part is an activity just for us to experience something. Remember our goal. Our goal is to think of more ways to help people learn. So I'm just doing an activity for you to have some things to think about. So all of you would have people around you, your friends. Remember, one group talk about importance of collaboration in the learning process. Collaboration is important based on 2 learning theories. Some of you might remember the names of the theories. That's right, Vygotsky. So Vygotsky gave us a theory to remind us, make sure students are not isolated when they learn. So nobody can learn sitting there by themselves. They always need people to talk to, people to interact with. So Vygotsky emphasized interaction. And Piaget, among many things, emphasized conversation. So conversation is informal. Learning requires informal language. Eventually, things become technical. When you teach economics, you teach them some technical jargons. Theory of demand and supply. The PPC, that, some people may not know what you're talking about because those are specialized terms that economics teachers use. Yes, eventually, it becomes technical jargon. But the start of the learning of technical things begin informally. It's a theory by Piaget. You cannot start teaching photosynthesis by saying, boys and girls, here's a definition of photosynthesis. If you do that, please don't tell anyone. Just stop doing that. Because that's not what a teacher does. That's not what a trained teacher does. Yeah, you cannot say, boys and girls, today we're going to learn photosynthesis. Here's a definition. Copy it down. Memorize it. Don't do that. If you do, don't tell anyone. Just stop doing it. Yeah? Don't tell anyone you do that because they will not think that you're a teacher. Yeah? That's not what teacher does. Maybe parents who are not teachers might do that. But you don't blame them because they're not trained. They're not professionals. But we are. We don't do that. Yeah? So eventually they will learn photosynthesis. Eventually they will learn the definition or a paragraph to explain what photosynthesis is. They will learn all the equations describing photosynthesis. But at the start of it all, it starts with conversation. Informal language. A language that even a 5-year-old can understand. A common technique used by a teacher is explain this to a 5-year-old. Yeah? Maybe a mathematics teacher wants to teach rotational symmetry. And the teacher may say, boys and girls, we have learned about rotational symmetry. Journal writing for today. How will you help a 5-year-old understand rotational symmetry? That could be a journal writing. Write in your journal what you might do. You can draw comics if you want. You can draw pictures if you want. But what will you do when you try to help a 5-year-old understand whatever we understood today? Rotational symmetry. Could be a journal writing in a mathematics classroom. So Piaget talks about the importance of conversation, informal language. And Vygotsky talk about the importance of interaction. Interaction and conversation. Yeah? So this activity is basically allowing you to interact, allowing you to converse, to give you the experience, and we'll see what the activity is about eventually. Anyway, in this activity, what shape do you expect to produce when you do the following 2 things? Yeah? So class, today you are going to be doing only 2 steps. 2 things. And once you're done with the 2 things with the paper, the question is, what shape do you expect to produce? Yeah? So start by not doing it. Start by just imagining, talking, guessing, speculating. And then once you're done with the guessing, then you act it out. You actually do it. Yeah? So what do you have in your hand is a paper. What shape is it? It's a square. Okay. The 2 things you're going to do. The first is, do you think you can fold it to produce a triangle? Can you fold it in half to produce a triangle? Right. That's the first thing you're going to do. The thing is, you can do it as many times as you want. Can you imagine folding it 2 times to produce a triangle? Yeah, which means you get how many triangle in that case? So you fold 1 time, you get how many triangle? 1 or 2? 2. And then you fold 1 more time, you get 4, and then you keep on folding. I don't know how many times you can fold. Yeah? So that's the first thing you can do. Fold square into triangle. I suspect you'll start with 1 time, then later 2 times, later 3 times, later 4 times. Don't know 5 times possible or not, I'm not sure. Second thing you want to do. Once you get a triangle, the second thing you want to do is to cut it. And how do you cut it? We cut it like this. So the triangle, and roughly halfway through, almost parallel to the longer side. Yeah? You want to just cut it across 1 straight line. Yeah? Tell each other what are the 2 things you're supposed to do. Yeah? Just tell each other what are the 2 steps. What are the 2 steps? All right, before you begin, any clarifying questions? Any group would like to ask questions to clarify what you need to do? Anyone would like to ask any question if there's anything you need to clarify? You make 1 fold, you cut it. What happens? What shape do you expect? You make 2 folds, you cut it. What shape do you expect? You make 3 folds, you cut it. What do you expect? You make 4 folds, you cut it. What shape do you expect? And continue. 5 folds, 6 folds, 7 folds. I'm not sure how much muscle you have. You need some muscle to cut it later. So that's your problem. Do you expect the shape to be the same all the time? Anyway, what shape do you expect? Any group have any clarifying question? If not, go on. Talk, and then later experiment. Yeah, you have scissors, you have friends, you have paper. You want more paper? There's more paper on my table. Just walk up and get it. Talk to your friends, 5 to 10 minutes. Let you just figure out what shape do you expect. All right, over to you. I'll leave you alone for a while. Sorry to interrupt you. So, yeah, let's share with each other what we have managed to get. Any group would like to share with us something? Anything at all you want to share with us? Any group would like to share an observation with us about the shapes that you managed to produce? Anyone would like to share with us?
Bapak Ibu mungkin ada yang mau share, ada sesuatu yang ditemukan di kelompoknya, entah menemukan pola tertentu atau apapun itu, silakan. Raise hand, nanti kami antarkan mic-nya ya.
Something you want to share with us about the shapes that you managed to get?
Okay, from our group, we found several shapes that we didn't expect to have. Our first, this is the first shape with 1 fold only. This is the 2 folds, the shape of the 2 folds, the same as the one there. This is 3 folds. This one is the 4 folds. 5. The last one is 8
And not
folds.
on the screen, yeah?
Not on the screen.
Yeah, thank you for that one. So, yeah. So the first group share with us the shapes they produce. Yeah? So they make all these shapes and one more. Yeah? They also share with us they got shapes they didn't expect. Yeah? Thank you for that sharing. They share with us the shapes they got. Do you agree with the shapes? Do the rest of the group have the same or somewhat the same as the first group? With 1 fold, 2 folds, 3 folds, 4 folds, 5 folds, and then 6 folds. Any other group got 6 folds? You also got 6 fold. You also got 6 fold. Yeah? Oh, okay, you all got 6 folds. So quite a few group got 6 folds. Yeah. What do you expect the 6th fold to look like? Right, thanks for that. Any group want to share with us something else here and then, yes?
Okay, good morning, Lashuman.
Morning.
Yeah, for our groups, we made 6 folds until 6 fold, and we found like some patterns. At first, I thought it was about square only, but it's not, because one square is made by two triangles. We found that every even folds, it produced missing square in it,
In
like
the middle.
inside the.
So you were saying this
patterns.
one?
Yeah.
So they were saying the even number, 2 fold,
yeah,
4
fold,
fold,
4 folds, and
6
6
fold.
fold, because we made until 6.
You get like the square
Yes.
and a square hole in the middle.
Yeah, even like the number of the square that a hole, it has like a pattern. It increase,
It increases? Yeah,
yeah,
it
it
increases.
increases.
So
Like
increase
start-
from 1 to 4, yeah?
Yeah, 1 to 4, and the next one is 16.
16 like this one,
Yeah,
yeah?
1, 4, 16, which is
The one that
perfect
they share
square.
with us.
So
Which is what?
perfect square, 1, 4, 16.
What do you mean by perfect square?
The square number. Sorry.
What do you mean by square number?
The number of the square in the
Oh,
paper.
so the
whole.
number of hole, the square hole,
Yes.
you say is 1, 4,
And
16,
16.
and those are called square
Yes,
numbers.
square number.
Those are called perfect
Yeah,
squares.
yeah. But there is no per 9. I
Oh,
just
that's
wanted,
interesting. So square numbers, 1. So how do I produce a square number, by the way?
By squared an integer number. Like
Oh,
one,
like 1
Yeah.
square of 1.
Yeah.
Like
squared of
1 times 1.
Yes, times
Oh,
1.
so 1 times 1.
Is
The next
one.
one is
2 times
2 times 2. And this one is,
3 times 3, but there is no 9 in
Oh,
here.
there's
I
no
just found the characteristic of the
oh, how
numbers.
interesting. So it's square number, but doesn't follow. You go like square of 1, square of
Yeah.
2.
Square
Next
of-
one is square of
yeah.
4.
Yeah, 4.
Oh, how interesting. Thank you. Thank you. Oh, how interesting. So the second group share with us a pattern. The pattern for 2-fold, 4-fold, 6-fold. And the pattern is square hole. And the number of square hole is, they say it's a perfect square. 1 times 1, or square of 1. 2 times 2, square of 2. And then now becomes square of 4. What happened to 3? Disappeared. Anyone managed to make 8-fold? Oh, maybe it's humanly impossible. Oh, not humanly impossible. It's physically impossible. But maybe the mind can do it, yeah? Can you imagine? Do you think you know how the shape for 8-fold look like? Physically, we cannot make it. At least nobody make it here. But mentally, we can think it. That's why we are given a mind. We are given a mind to do things our body cannot do. Yeah, so our fingers and our arms don't have enough skill to make 8 folds. Any group manage 8 folds? No, So it seems like physically not so possible, given the limitation of our machines, which is a pair of scissors. Maybe, with better machine, maybe, I'm not sure. I think possible if you got some machines. or the paper, maybe this too thick for you to cut, I'm not sure. Anyway, but definitely our mind is possible. I'm just wondering if you're able to imagine with 8 folds. Yeah, thanks for that sharing. Third group, yes, another group want to share something? Yes, please.
Thank you. I'm not really sure that if I jadi wakil dari grup, but I try to remind us guys, we do not, kita tidak cuma bikin bentuk ini loh, tapi kita juga ada bentuk ini yang kita hasilkan.
The leftover, yeah?
Yeah. I don't think that is the leftover. Sorry.
The cut
Kita
out.
tidak cuma bikin bentuk yang ini, tapi kita juga bikin bentuk yang ini. I mean, we didn't just make this kind of shapes, those kind of shapes, but we also.
Where does that come from? From here. Oh, okay. The cut out, yeah?
Yeah.
Oh,
I mean,
thank you.
I mean, I do not know. As a teacher, maybe kita tidak, jangan sampai kita cuma kalau ngajar muridnya jadinya sama semua. Apalagi kalau di sini kan kita mikirnya tergantung anaknya nanti jadinya kayak apa. Itu sih. Thank you.
Yeah, thanks for that. Oh, so the third group share with us something interesting. The shape that is cut out. Yeah, so some of you pay attention to that as well maybe. The shape that is dropped out. Do you notice something special about the shape that is dropped out? Any of you have any observation about the shape that is dropped out? Talk to your friends for half a minute. What about the shape that is dropped out? The one that some of you threw away, but they pay attention to it, yeah? What about it, yeah? Talk to your friends for half a minute or 1 minute.
Oke teman-teman, lausemen, Tadi kan kita udah bahas shapes atau bentuk-bentuk yang kita dapatkan, tapi bagaimana dengan yang dipotong, yang terbuang? Apakah ada pattern juga? Atau adakah sesuatu yang bisa diobservasi di sana? Silakan diskusikan teman-teman.
What can you say about the shape that is dropped out? Is there some pattern for them as well? Any group would like to share some pattern you might see about the leftover piece that some of you say sometimes we don't pay attention to, like some students in our class, we don't pay attention to them because we think they are not so important. But maybe they are important as well, yeah? Good analogy, I think. Good metaphor, I think. And anything interesting about those shape that is left over?
Apakah teman-teman ada yang menemukan sesuatu yang menarik dari leftover cut? Guntingan-guntingan yang tersisa itu? Atau cuman random aja? Oh, di sana.
Ada ya.
Thank you, Pak. Okay, what we found from our group that for the first cut until the fourth cut, there are pattern, which is the first cut, the leftover is a triangle. And
Triangle
then,
first.
Yeah, and then after that, the leftover cut is a square.
Square.
And then continue to triangle.
Triangle.
And then rectangle.
Rectangle.
Triangle. Apa sih? Square. Yeah.
So start with triangle,
yeah,
square.
Yeah,
Triangle,
square.
square.
But then after the fifth cut, the leftover, it's a combination. So it's a combination of triangle and a square.
Okay, thanks for that. So they were saying it start off with triangle and then square. And then triangle and then square. And then they say the fifth one is a combination. Really? Wow, how interesting. Is the combination because of the imperfection of you cutting? Or is it really happening? It's really happening. Oh my goodness. How interesting. How interesting. Yeah? So earlier, the other group was saying also, the leftover is also important. Now in English language, we call this a metaphor. Yeah? A metaphor is a language device. Yeah? So this maybe is a metaphor. I'm not sure whether it is. I'm asking you. Yeah? So maybe in English we learn about metaphor, yeah? And then, do you think this is a metaphor? So, here we were saying, so many of us were paying attention to the main shape. And then we don't bother about the leftover, the one cut out. But one group was saying, oh, they are not the leftover. They may be also important and interesting. Do you think this is a metaphor for maybe students in the class? Or just people in general? Sometimes we think that some people are more important and we pay attention to them. Sometimes we think that some students are more important. They learn well. We pay attention to them. And then we think that some people or some students, they don't matter. It doesn't matter. But our friends were saying, maybe they are also interesting. But you must be looking at them. You must pay attention to them. And here, because we pay attention to the leftover, we found something so interesting, so intriguing. Like you got a mixture. Yeah? So sometimes interesting people are not clear cut. Yeah, they are not so clear. Because here is not clear anymore. Triangle, square. Triangle, square. And then suddenly a mixture. It's like so messy. And that makes things interesting. So I'm just wondering whether this can be called a metaphor. So in English language class, we are learning about metaphor. I'm just wondering if this can be a metaphor. Anyway, maybe one more interesting observation. Any group have something more you want to share with us about the shapes? Any more pattern about the shapes that you notice? Yes, please. What else did we notice?
Maybe untuk apa namanya tadi itu? Lipatan kedua dia menjadi one square, lipatan keempat menjadi four square. Berarti tadi lipatan keenam menjadi 16 square. So lipatan ke-8 maybe 4 pangkat N-1.
Okay, maybe, yeah.
64 square. 64.
So you were saying 1 square, it comes from 1 square of 1, yeah?
Yeah.
And then we got 4, yeah? Come from square of 2, yeah? And then the next one is, you say 8, is it? Is it 8?
No, 16.
Yeah. So when we make a mistake, we don't need to erase it away. We just cross it out, yeah? In mathematics, we don't like to erase things away. Just cross out neatly, yeah?
6.
This is no good also, yeah? So in mathematics, we always cross out neatly. And you were saying 16, yeah?
For 6 fold, that is 16.
After 4 is 16, yeah? And that comes from square of 4. And then the next one you were saying maybe come from where? Whatever the number.
8 fold, that is
Come from square of what?
8 kali 8.
Okay, square of 8, yeah?
Yes.
Yeah, so maybe, yeah, you're saying, okay, thank you. So I wonder how they decide this number. Because it's not 1, 2, 3, 4, yeah? It's 1, 2, 4, 8. Then the next one will be what? Is it neat? The next one will be what? I mean, this one doesn't matter. We can just calculate, yeah? Like, next one will be, what is that number, yeah? A numberless. Why a numberless? But why a numberless? Oh, so you're saying this one? Is it? So you're saying it's double? The ratio is? Or the ratio is always? So I don't know how to say it. It's like 2 to 1, yeah? Is that right? Okay. Oh, how interesting. Yeah, how interesting. Okay. So, number of folds, I got no space to write, yeah? So I use language of algebra. F stand for number of folds, yeah? So, in algebra, we always use letters to represent quantity, yeah? Here I don't have space to write, so I use a letter. But this is what we do in algebra anyway. So F is number of folds. So you were saying number of folds is 1. Number of folds is 2. Number of folds is 3. Number of folds is 4. Number of folds is whatever, yeah? Maybe n, yeah? Any number, like 5 or, yeah? Okay. Yeah? Go on, please. Yeah? Yeah? It doesn't start with 1, yeah? Oh, so you're not talking about this one. You're talking about even number of folds, yeah? So this is a mistake. Remember, class, what we do when we make a mistake? We cross it out, yeah? So this is not what you meant, yeah? So you were saying the first one is actually 2 folds. Oh, the first shape comes from 2 folds. F equals to 2. And the next one comes from 4 folds. The next one comes from 6 folds. The next one comes from 8 folds. And the next one comes from 10 folds. Okay. Thanks for that. Okay. Right. And when the value of f is, example 10, I wonder how many squares are there. So this number of squares, S will be number of, I call square holes. I always put in inverted comma. Yeah, so in English language we learn punctuation, yeah? And the purpose of inverted comma. I think a lot of us do this when we talk to people as well. When you say something, sometimes you do this action, yeah? So this is number of square holes. So whenever we say something that is not, actually it's not a common word, like square hole. It's such a strange thing, right? But it's make people understand, yeah? Square holes, yeah? So number of square holes is S, and you're saying that the number of square hole is like this, yeah? Okay. So maybe I put this in a table. Yeah? So in mathematics, we like to do things like that, yeah? Organize our thinking. All right. So you're saying the ratio of any shape, the ratio of any number of square holes to the one before it is 2 to 1. How can I write it using notation, yeah? Mathematics teachers, you will know this, yeah? But the rest of us, maybe you'll remember, yeah? Okay, we're going to have break soon. So let's finish up. So your friend was saying the ratio is 2 to 1, yeah? The ratio of what, yeah? Do I mean S here? So I'm referring to the color in blue, isn't it? So maybe I need to use another letter. So S is not a good choice here because S is not what I'm referring to, yeah? So maybe I create another letter here. Not sure how many, this is a number. Maybe I call it X or Y. Up to you, you can choose whatever letter you like, yeah? So this number here. Yeah? So the ratio of, maybe I call this Y, yeah? The ratio of Y to the one before it. Is it? The one before it. The one before it. Yeah? So the ratio of this number to the one before it is always 2 to 1. Okay. All right, class. So our lesson today, yeah, your job is to now be able to write a general formula. Do you think you can write a general formula for the number of square holes? Yeah? For whatever number of cuts. The number of square holes. Right? So that will be the rest of the lesson. Okay? We'll stop here. After the break, we'll talk a little bit about the lesson, and then we'll do a little activity before we finish. But now it's break time, so we'll have a little break, yeah? So break time, and you will tell the class what to do.
Ya, terima kasih buat teman-teman yang sudah mulai move sedikit ke depan ya, nggak apa-apa ya. Baik, kita akan melanjutkan sesi kedua, dan sesi kedua akan berjalan sampai jam pukul 10.45. Setelahnya nanti dari 10.45 sampai 11.15 akan ada sesi tanya jawab, jadi dimohon untuk Bapak Ibu semuanya untuk mempersiapkan pertanyaan-pertanyaan yang kritis dan kreatif ya. Baik, waktu dan tempat saya kembalikan kepada Dr. Yeap. Beri tepuk tangan yang beri Bapak Ibu.
Thank you. Welcome back. So today we are thinking about how to increase ways of helping students learn. Yeah, and this link back to the 6 elements of lesson where students need to have experiences like exploration and also guided by the teacher in a structured discussion. Journal writing, reading, reflecting, practice, things that you know already. And then we are starting to also start thinking about linking subjects together. So of course, STEAM is a big thing. But the starting point is just make connection in different subjects. The simple activity that we did, yeah, clearly I did it with you like a mathematics lesson. Yeah, so this could be a grade 9 lesson on indices, exponents. Yeah, because in the concept of exponent, we want students to understand one action, the result is exponential. Meaning one action, if you double it, the result is not just double. So that's a main concept you want students to understand in mathematics when they learn about exponent and exponential function. That one action result in a bigger outcome. Like just double the fold. The number of square holes or the pattern changes. Yeah, that's a concept. So the way I did it is for mathematics. To learn exponent and exponential ideas. If I am an English language teacher, and earlier you saw me do a glimpse of it, I do a little bit of that. So if I'm an English language teacher, maybe that day's lesson is on the language device of metaphor. So whether it is Mandarin or English language or Bahasa Indonesia, we teach students different language devices. And in English language, among many of the language devices they learned, one of them is metaphor. So metaphor is when you use the quality of one thing to describe that of another thing. That's metaphor. I might say, I'm drowning in work. Doesn't mean you're drowning. That's a literal meaning, isn't it? That's a literal meaning. So literal means actually happen. Like I'm drowning means I'm like dying because I cannot swim, yeah? So if I say, I'm drowning in work. So I'm using the quality of one thing, drowning in water, to convey the meaning of me barely coping with my work. It's like I'm overwhelmed with work. It's too much work for me. I'm drowning in work. I'm not doing very well. Because when you're drowning, you're not doing very well. You're struggling to keep alive. You haven't drowned yet, but you're drowning. So you're like dying. But when you say I'm drowning in work, doesn't mean you're dying. Just like, oh my goodness, it's so much work. So that's a metaphor. You use the quality of one thing to describe the quality of another thing. So quality of swimming, drowning when I'm swimming, to describe me not doing well in work. Or we can say, she's such a nice person. She has a heart of gold. Please don't cut her up. There's no gold. It's just a bunch of tissues. Her heart is still organic. It's not really gold. But we use the quality of gold. Priceless. So when you say gold, it's often something precious. To describe the quality of that person. Metaphor. Yeah? Or you can say, he's a couch potato. You're not saying he's a potato. He's not a potato. Please don't cook him in a curry. He's a person. But he's a couch potato. Yeah? So, metaphor. So, if I'm a teacher teaching English language, a lesson on metaphor, I can connect it to this lesson. Because in this lesson, it can also be used to teach students the value of not ignoring anything. Sometimes, the thing that we usually ignore may turn out to be more interesting and maybe even more important. Because in this activity, most of us will pay attention to the main pattern, the main shape. And we always throw away the one we cut off. It's quite common, being human. So it's a good activity to trigger. I think a moral teacher can do that as well. I'm not sure whether a moral teacher will teach something like that, but I'm sure somewhere in the lessons in school, they will have lessons along that way. Lessons that teach them values. Because this is part of value. Being not judgmental, being not biased. When you throw away the piece you cut off, actually you're biased. Maybe it's human to be biased. And that is why we have lessons to mitigate that problem, to reduce that problem. So by nature, being human, we tend to be prejudiced. We tend to be biased. And the lessons that you give them, whether it's in ethics or values or moral or pastoral care, whatever you call them, I'm sure some of you here teach these things. But I suspect every teacher is also teaching these things. So if I'm having a lesson to discuss that, I can use this as an activity as well. So this can be a trigger activity for people who are teaching students to lessen biasness that we humans are born with. Our human brain is designed to differentiate, to discriminate. We look at superficial things and then we become prejudiced. And no wonder many of us will just cut the paper and throw off that piece. But some of you seems to also look at that piece. So this will be a good starting point for that kind of lesson. I suppose if I'm a language teacher, I could also get them to say, to do this. I'm sure in languages, for sure in English language, you teach them different types of writing. Some writing is more informational. Some writing is more descriptive. So different types of writing. Argumentative writing. Yeah, different genres. I'm sure all languages teach that. And one of the writing style we teach them is like writing the recipe of cooking your favorite dish, or writing the procedures in a science experiment. So you could get them to practice doing that kind of writing, because there are some things they need to pay attention to when they write steps for people to do something. So I can focus on that if I'm a language teacher. Oh, today you did this activity already. You seem to be quite good at it. What about telling people who are not here with us, who do not have a chance to ask clarifying questions? Because today, I told you what to do, and you have a chance to check with me what you needed to do. But when someone buys an equipment, and the manual comes with it, that person often do not have a chance to ask anything unless they contact the customer service. So, of course, you hope they don't contact the customer service, because then customer service will be overwhelmed by the millions of customers. So your manual should take care of 90% of the customers. Yeah? So can you think of a way to write the manual for the activity that we just did? So that could be the language connection. So what I'm trying to get us to see here is that any activity probably have many linkages to the different subject areas that students learn. Science teachers, chemistry teachers, physics teachers, biology teachers, can you share with us one phenomena in your subject area that follow the same pattern, the same consequences? Yeah? Where the change go from 1 to whatever the number is, yeah? 1 to 4 to 16, yeah? Anything from biology that goes like that? Biology teachers? Anything in physics that goes like that? Anything in chemistry that goes like that? Is there? I'm not sure. I don't teach sciences, so I'm reliant on our experts in the room here. Yeah, are there scientific phenomena that follow the same? I mean, you don't have to be science teachers. Maybe you know something. You can tell us too. Huh? Say again? Oh, so you're describing the Fibonacci sequence. So Fibonacci sequence. So in nature, we sometimes also see things that changes in a certain way. Yeah. So this is a pattern. Like you start with 1 and 1, 1, and 1. 1 and 1 is 2. Yeah. 1, 3, 2, and yeah. So there are some pattern like this. Yeah. Yeah. And they call that Fibonacci sequence. Yeah. So they are saying that in nature, like the number of petals in flowers or other observations you see in nature follow this pattern. Yeah, thanks for that. I'm referring specifically to this particular pattern. Yeah, this particular pattern. Is there something that is also exponential in biology, in chemistry, in physics? Is there? Huh? Cell division? You say amoeba, right? Amoeba. All right. So amoeba is a one-cell organism. Amoeba, yeah? So it's an organism that is also one cell. I mean, for us, we have too many cells, yeah? But amoeba is an animal, just one cell. And amoeba reproduce by splitting in half. So one amoeba become two amoebas. Forgot what's the plural for amoeba. Amoebae? Amoebas? I don't know. Anyway, one amoeba become two amoeba. And then 2 becomes 4. Yeah? Is that right? Yeah. So that's under reproduction of single cell organism. Yeah? So in biology we have that. Reproduction. Yeah? How about chemistry? How about physics? Is it? Yep. What is it?
Maybe for chemistry is the total number of electron of each shell.
Number of electron in the different shells.
Yeah.
Like in, let's say, an atom of oxygen. Oxygen has 16 electrons.
What I mean is in atom there is shell number 1, shell number 2, shell number 3.
Yes.
And each shell has the total number of electron. And we calculate it by 2n square. Jadi shell number 1 will have 2 electrons, shell number 2 will have 8 electrons, shell number 3 will have
18 electrons.
2, 8,
So they were saying that in atoms, if you still remember a bit of your chemistry from secondary school, the most current model for atom, not the most current, but the most basic current model of atom is basically one with a nucleus in the middle, comprising of mostly neutrons and protons, and then electrons circulating around the nucleus. And they circulate in orbits, what we call shells. Yeah, so there's a first shell that has a maximum of 2 electrons. The second shell that has a maximum of 8 electrons, and a third shell that has a maximum of 18 electrons, and the number of maximum electron in every shell follows a formula. Yeah, so they were suggesting that it is, yeah, something like that. Anything else that you can suggest? Anything else in physics, chemistry, biology where you might go from 1 to become 2, 2 to become exponential? Yeah? 1 becomes 4, 4 becomes, anything else that goes like that? And then the change becomes so fast. Before you know it, oh my God, there are so many amoeba around already. Yeah? So the increase becomes so rapid. It doesn't double. It goes exponentially. Anything else as exponential in physics? Kinetic energy. How kinetic energy changes with speed. Oh, so kinetic energy changes with speed for a given mass. For a given mass, it seems that the kinetic energy increases exponentially as well. Oh, that's the meaning of the formula. Because in physics, I hope I remember some physics. In physics, they learned that the kinetic energy, if I use a letter E to represent it, is related to how heavy the object is, as well as the speed, but it's represented like that. Yeah? So while you double the mass, half of it, yeah? So while in the case of mass, if you double the mass of the object, the kinetic energy will just double for a constant speed. But in the case of speed, so you double the speed, the energy changes by so much. You double again, it increases. Oh, so that is the meaning of exponential? Is it? Okay. So interesting. Yeah, it changes like that. Yeah. And maybe some of you may think of radioactive. Yeah, radioactivity. Yeah, again, nuclear fission, where the nucleus break up. 1 becomes 2, 2 becomes... So there are so many. So I would imagine the science teacher may say, well, in your mathematics lesson yesterday, in that lesson on paper folding and cutting, all of you saw how the pattern changes in an exponential way. And today in our class, the chemistry teacher said, oh, some of us gave the example of number of electrons in shells of the electron. So the teacher may now say, well, today's lesson is for us to check exactly how it changes. And more importantly, why it changes. Why are the number of electrons in the different shells not the same? Let's investigate. You have a few sources, 3 videos to watch, 1 page in a textbook to read, and together in a group of 4, 20 minutes, go and explore possible reason based on your own thinking, but supported by the 3 videos and the textbook page. By the end of the 20 minutes, come up with a proposal, a possible, maybe plausible reason why that happens. Or in a physics class, oh, today you had chemistry lesson, yesterday you had physics lesson, and yesterday you had maths lesson where you did paper cutting and folding, and you saw about how the number of shapes changes in an exponential way. And some of you were suggesting that maybe kinetic energy changes with speed in the same way. I'm not sure. Today, we want to investigate how different forms of energy in a moving body changes. That's our anchor task for today. How do different energy forms in a moving object? You choose your own moving object. Can be you running, can be a car moving, can be aeroplane flying, can be a billiard ball bouncing off the billiard table, or whatever that interests you. Pick a body, treat it like a particle, and then 20 minutes, discuss with your friends how do different energy types, one example is kinetic energy that came out a while ago, but I wonder if there are other energy forms when an aeroplane is flying, or when you are running the 100-meter race, or the billiard ball is being struck and bouncing off before it fell into the net. I wonder if there are other types of energy. Anyway, find out how they change. Do they change in an exponential way? 20 minutes, 3 videos to watch, the following pages in the book to read, 4 of you investigate. For the given object that you have chosen, what energy forms does it have? And how does the energy changes if they change? In particular, is the change exponential? Since in the maths lesson yesterday, we learned about exponential function. Oh, today you have biology. Earlier today you have physics and chemistry. Yesterday you have mathematics, where you saw how the shape changes in an exponential way. Today in our biology lesson, some of you suggested reproduction in single cell animal happens that way. And that's our topic for today. And you can imagine how over the next few days, in a different subject area, different teachers can refer back to the same activity that they did on Monday in a maths lesson, and how to link together different concepts using a simple activity like the paper cutting activity. So today's session is to give us the first step towards STEAM education. STEAM, of course, is much bigger than that. Today, our focus is just to think of possible lessons where different departments can collaborate in some ways to help students see that they are not just going to random classes. I go to chemistry, I learn one thing, and that's it. I go to English, I learn something else. That has nothing to do with my chemistry. Their experience as a student is disconnected. They don't have a good customer experience. Whenever you go somewhere, you want to have a good experience. It's called customer experience. That is why some companies are better than others. If you take the airline industry, some of you have your favorite airlines. For me, I like Singapore Airlines. Because when I go to Singapore Airlines, I bought the plane, I buy the ticket, I do check in. I have a nice customer experience most of the time. I got no choice, but sometimes I need to take United Airlines. I don't like it because I get a different customer experience altogether. So customer experience is an important thing. We often do not think of students as a customer, but they are. Because they pay money. I mean, in this case, their parents pay money. In other cases, the taxpayer somebody paid money. Whether it's the government, the taxpayer, not the government don't have money, taxpayers' money, the government used it, yeah? Whether it's the taxpayers' money or their parents' money, students are really customers. When they come to school, for them to learn well, they must have a good customer experience. Just like for me to travel well when I fly, I need to have a good customer experience. Yeah? So in order for students to learn well, we must provide them with a connected customer experience. So, not so good if they are just going to random things, and they may not see the connection, and sometimes they'll be asking, why am I in school? I'm supposed to learn. Am I learning? Or worse, they don't even ask these questions. They are like robots coming to school every day, go home, and they don't think about why they are here. So this is the first step. Can we start by making a small step? Every once in a while, meet another department and say, hey, what are you all doing this week? Maybe you can find some connection. Once in a while, once a term, 4 times a year. Meet another department, make some friends. Also find out what they teach. Learn something maybe like, oh, I didn't know there's such a thing called amoeba, or I didn't know like in nature there is this interesting thing called Fibonacci sequence. Make some friends, yeah? But more importantly, find some common linkages, because linkages are actually very common across subjects. The division of subject is actually artificial. Long time ago, the same teacher in Renaissance, the period of Renaissance, the same teacher teaches everything. Because it's not what they teach that's important, it's what students learn that's important. The content is not as important as them learning how to learn, them learning to be a better young person. That's really the outcome of all of us in this room. At the end of the day, who cares about amoeba reproduction? It's not that exciting anyway. Who cares about electrons in a shell? Because most of us will not become a chemist anyway. But learning how to learn is applicable to every single student whom you are teaching. Learning how to learn. The electronic structure is just the platform. The exponential function is just the vehicle. The real outcome is learning how to learn. The real outcome is learning how to be a good person in society. That's really the goal. And the same person can teach the students anything and everything under the sun. That used to be the case. And then these days we become quite specialized. And there's some danger in specialization, because then things can become disconnected. Today's session is just an urge for you to every now and then try to make linkages for the students. Not just by saying it. Not like, oh, by the way, exponential function is very important in your life. And then that's it. Just saying it, not really meaning it. Yeah? So for the next few minutes, I would like you to just move around, but move around as a group. Yeah? As a kelompok, yeah? So your group comprises of your colleagues teaching the same subject, maybe the same grade level. Yeah? So maybe like SMP 1 English teachers. If you want a bigger group, you can combine 1 and 2, up to you. But I think same level, same subject, form a kelompok, and just move around. Try to meet 2 or 3 other groups and think probably the same level. Yeah, like, you teach mathematics, SMP 2. Or you teach history, you teach humanities, you teach IPS, SMP 2. Just meet with some kelompok, 2 or 3, and exchange idea. Perhaps a common lesson that might be possible between the 2 subjects. Yeah, hopefully in 10, 15 minutes, you can talk to about 2 groups, 3 groups. But let's take 15 minutes for this activity.
Baik, teman-teman Lausemen, silakan mulai berkumpul pertama dengan teman sejenjang, maksud saya segrade dan subjek yang sama, diskusi dulu, kemudian move around ketemu dengan kelompok lain di grade yang sama, subjek yang berbeda, terus coba diskusikan kira-kira topik apa yang bisa dikoneksikan gitu ya, dari 2 atau 3 subjek yang berbeda. Silakan Bapak Ibu, kita punya 10 sampai 15 menit ya.
Alright, sorry to interrupt all of you. So I'm really glad you have a chance to talk to other people. You can just sit wherever you are or stand wherever you are. We would like to hear from some of the groups. Just very briefly, an idea that you have with another department, another subject area. Yeah, if you can share with us briefly what you talk about. Maybe you can hear from a few groups. Yeah. So which group is excited to share with us something you would like. Yes, please go ahead. Anywhere you wish, the camera will follow you anyway.
Oh, yes. My name is Sudraja Saputra. You can call me Ajat, sir. Yeah. I'm from grade 7 on SMP. This is already I do before last 2 years, yeah. 2 years ago. 2 years ago, I collaborate with my friends Steve, yeah, on physical education, sport, not sport. I'm a physics teacher. So the activity is athletic, lari, running. The problem is how runner can maintain speed to achieve the best performance to maybe competitions or something. And then we collect the data in every 10 meters, we stop the stopwatch to have the time and the distance, time and the distance. And we collaborate with math, so math can teach to make a graph from time and distance. And the physics is elaborate the graph to find the speed, the average speed for each students. And my beautiful friends from Mandarin and can make the reports with Mandarin language. I think that's all, sir.
Thank you.
Okay.
Yeah.
Maybe I can show you the 2 years ago video when we collect the data.
Yeah, maybe you can zoom in to show us.
This is on the PE lessons to collect the data run from the students. Okay, thank you, sir.
Thank you very much. So we hear an example. Yeah, you hear the example already. The main problem, sometimes we call anchor task, is how to maximize your performance on a track event, in a running event. How to maximize your performance. In other words, how to win, or how to be as fast as possible eventually. Yeah? Should you run very fast at first? Or should you run very fast in the end? That's a question. Like, how should you moderate your speed? And that may vary from event to event. So they may think about, oh, what about a sprint event? I think in sports, sprint might be 100 meters, 200 meters. Is it 400 meters still a sprint? Maybe. Not for me. 400 meters is jogging for me, yeah? But in sports, I think 400 meters is still a sprint, yeah? But what if it is a middle distance, like 800 meter or 1,500 meters? What if it is long distance, like 10,000 meters, yeah? So maybe students can investigate one or more events, sprints, middle distance, long distance, could be marathon as well. But the main problem is, how can we maximize, how can we optimize our performance in a running event? By changing our speed throughout the race. Yeah? And you hear how there is application in physics and mathematics, clearly. And also in sports science, in physical education. And of course, language can always come in. It can be English language, it can be Mandarin, it can be Bahasa Indonesia, because writing report can happen in any languages. It'll be interesting to see how they write the same thing in all three languages. Yeah? So that's an example. All right. So I suspect in the coming school year, SMA teachers, you are going to have more time for your subject area, because Pahoa is now evolving into the next stage where they like to calibrate the quality of learning with international standards. And the international standard is that in grade 11 and 12, students become more specialized. They spend more time in fewer subjects. And when you have more time, what can you do with all this time that you have with them? And one of the things is moving towards an integrated learning. Some people call that STEAM. Doesn't matter what we call it. The idea is, can we give students a better learning experience where they get to explore? You can see the exploration, yeah? And then later they come to some ideas. In physics they learn this, in maths they learn that, in PE they learn this, but all in an integrated manner. Perhaps we hear a second example. Another group would like, it's excited to share with us. Yes, please.
Okay. I think I want to, can you zoom my screen please? I want to everybody can see what we have done with my groups. So, is it okay? So, in grade 9, we are discussing about the population growth, and we are trying to collaborate with 4 subjects. That is the first one, global citizenship, with the topic is sustainable development, and the biology is reproduction system, and with maths that is statistic, and then citizenship is keeping national culture. So this is the final project that this is from the brainstorming, how to make population growth report using the mathematics. This is the one we are trying to do that, to make, to collaborate for subject about the population growth in grade 9. Thank you.
Thank you. What's the first subject again, GC?
Global citizenship.
Global citizenship, yeah? I suspect in global citizenship, thank you very much. So I suspect in global citizenship, I suspect that can also be in a geography lesson, yeah, because you do learn population, an important topic in geography, but in this case, in global citizenship, they learn this concept as well. It's a social study notion about population growth, population change, yeah? So you can see another example, yeah? And I suspect in this case, if there's another subject that talk about agriculture, yeah, not sure whether that is covered in any of the subjects that any of you teach, because population growth is related to food supply. So I suspect that's a topic that can also be related if any of the department happen to also need to teach this notion of sustainability in agriculture. Because with population growth, clearly we need to feed all these people, yeah. And I suppose the reverse of it as well. Population decline in developed nations, yeah, where there's no longer enough children to maintain the population growth that is necessary. And what do these countries do? So countries like in Asia, South Korea, Japan, Singapore, where the population growth is declining at a rapid rate. So where are you going to find all these people to sustain the economy? So that's another discussion. So you can see, yeah, how it is really possible for any topic really. Yeah. So I really hope that some of these examples will eventually become a reality. Example, the one in PE and physics, maths, that has already happened before. So once every term, if you can make that as a goal for your department, just once every term, make some friends across department, do a little lesson together or a collection of lessons together, and over time we become more fluent with it, then you can do it more often. Yeah, you can start with something once a term, and then once we become familiar with it, it can become an everyday thing even. And I suspect 10 years down the road, good schools around the world will organize their lessons in that way. It's not even a new thing. In Singapore, there is one polytechnic that use problem-based learning as their main pedagogy. In fact, when they built the school building, they built the school building with that pedagogy in mind. Every morning, the students come, half an hour meeting to receive the main problem. And then throughout the day, they have various meetings to solve that problem or to get some summary or some structured discussion from their respective lecturers. And by the end of each day, they learn about something in different subject area, but everything they learn is never through a lecture, but always through the exploration and then the structured discussion. Along the way, they'll be reading some materials, but these days reading is more general, that include watching videos. They'll be doing some experimentation, either the actual experiments in the lab or sometimes dry experiment using some app or some devices, technology on their iPad. And they will probably be writing their journals, and sometimes a journal become bigger, like a report. So all the different learning experiences, from exploring to structured discussion, to reading, to writing, to reflection and practice, happens throughout the day. And the next day they come, they get another problem. Sometimes it's a follow-up problem from yesterday. Sometimes it's another problem. But over the period of one term, they learn whatever they learn. So it's actually not new. This polytechnic is 15 years old now. I think maybe older than that. So it's really not new. But I suspect in 10 years' time, this will happen in all the good schools globally. So at Pahoa, we want to now evolve closer and closer towards that way of learning. And the first step is to have more time, especially at the higher grade levels, per subject area, by reducing the number of subjects. Yep. So we have time, so maybe one more example at least. Another group who is excited to share with us. Yes, please.
Thank you, sir. From our discussion, we're teaching grade 11, and we found there are some topics that actually are related to one to another. We're from math. In math, grade 11 learn about the derivative, and then in physics actually the student learn about displacement, velocity, and acceleration. So actually, this is a good topic to combine. Like maybe we provide anchor task that has physics problem, but and then solve it by using the derivative. We know that the first derivative, if we have function that is the displacement function, if we take the first derivative, it's velocity. And then if we take the second derivative, it's acceleration. And then we found also that it has connection also with informatics. In informatics, the informatics teachers share that the students are asked to make program, and sometimes they also use the problems from math and also from physics, and they ask the student to make the program that relating to maths question or physics question. So there is a possibility for teachers in grade 11 from mathematics, physics, and informatics. Maybe we discuss further to make the same project or assignment. When the student do it in the group, the student will get 3 grades, the same grades that can be given to maths, physics, and also informatics. Thank you.
So thank you very much for that. Thank you, because that later sharing give us a new idea. how integrating subject, how using STEAM approach to learning can provide challenge for advanced learners, or in this case for all learners. You see, typically in physics, they would not use calculus in their problem. But because they learn calculus in mathematics, and it's integrated now with physics, now they are learning physics at a higher level. So this is probably a good example how integration provide higher level of learning. Under differentiated instruction, your advanced learners now are learning beyond what is expected. But not just advanced learners, actually all the learners are now getting an advanced version of the physics that they're supposed to learn. The second point that they mention is also how just doing one thing, one big thing, now allow them to get 3 grades, which allows students to have a better experience doing less, but learning more. Rather than them being busy all the time, and at the end of the day, learning less. So this and all the previous example gave us probably a good example if you're thinking about grading, how a common assignment, because otherwise the students will be so busy doing little assignments, but instead why not give them a big assignment, a bigger assignment, and just completing that allow them to earn grades across subject area. Likewise, in mathematics, very often they are given the equation to obtain the derived function. Here's a function, give me the derived function. But when you use informatics, you can model the raw data, from physics. So in physics, they collect data. In mathematics, we don't collect data. So now the physics give us a data, the informatics allow us to model the function. And then in mathematics, we do the derivative. So again, in mathematics, they are learning it at a higher level. Normally, they are given the function. But now, higher level. They model the function. They model the function based on what they get in physics. Yeah? So I think we have really good example this morning. I'm sure there are many other examples. Probably we won't have time to listen to all of them, but hopefully we are going to see them happening in the various classes. And during Audire, some of you will be sharing some of these examples. So we are excited to hear more examples after you have tried them. And we're going to end this morning's session here. So today we are really extending our classroom practices. By now, most of us are already into trying to do the 6 elements in a different lesson. Today's session is really a nudge for us to go one step more by trying to make connection across subjects. And that will eventually become what people call STEAM, approach to learning, problem-based learning. Doesn't matter what we call it. Pahoa will probably tell parents we are doing STEAM. It's essentially just letting students make connection across subject. All right, so we're going to end today. Thank you very much for your time this morning. Thank you very much. I'll pass it back to you.
Terima kasih untuk partisipasinya Bapak Ibu semuanya. Waktu kita sebenarnya sudah selesai. Mungkin kami memberikan kesempatan cukup 1 aja ya. Pertanyaan dari Bapak Ibu semuanya. Boleh langsung raise hand. 1 aja. Oh, ada di sana ya. Oke, silakan Pak Andi.
Yang mana nih? Dua. Oh.
Iya, 2 boleh lah. Pajak dulu silakan.
Oke. Ya, saya udah tulisin. Sir, I feel that the biggest enemies for teachers are time and results. For example, based on today's activity, some of my students, maybe just like me, might need more times to reach the goals. Even until the break, I figure out the odd and even function for the folding. Gitu. Yeah. I need more time to make a function for odd and even function.
Yeah.
I need to reach the sevenfold and even ask my partner for help to see the pattern and test my hypothesis before finally finding the function. My question is, could you please share your advice on the most effective way to overcome these two enemies, especially times?
So I think one important idea we need to understand is, it's not getting to the final answer that's when learning happen. You don't need to get to the final answer for you to learn things. A lot of things in life you never come to a conclusion. But many of us as teachers, we have this mindset that we must get to the answer. So do not worry about the answer. Some of us will get to the answer. Some of us will not get to the answer yet, but we are still experiencing learning. As long as students have the 6 experiences, you can guarantee learning, even if they do not arrive at the final answer. Some students will get to the final answer, some students will not. But as long as you can say they experiences these 6 things, you can be sure learning is taking place. The learning comes from the process, the experiences, not from getting a final answer. So do not worry excessively that some students are not getting to the answer. Second advice, more practical one. For those who need more time, the journal writing is a platform for them to take more time beyond the class time, to think more, to slowly figure out to the final answer. So the journal is a platform, because journal can happen anywhere beyond the classroom. So students may be halfway through, but when they finish their journal as a homework, that's when they complete the answer. So if you feel the need to get a complete answer, then I suppose journal writing is a platform. Yeah, so 2 points for that. Not necessarily to get to the answer, but if you still need an answer, journal writing is your main platform for that. Yeah.
Oke, satu lagi pertanyaan terakhir ya dari sisi sebelah kiri saya, silakan.
Okay.
Lausa.
Thank you, sir. I have 2 questions actually. This is about STEAM. From your first session, I have, this is my takeaway about STEAM, sir. The first one, STEAM is the integration of science, technology, engineering, arts, and maths. And the second one, STEAM is one of the design thinking approach. My question is, if I refer to my first takeaway, how far is a project can be called STEAM? If the project is the combination only 2 or 3, for example, only science and technology, and there is no engineering, arts, math, can we still call it as STEAM project or not? My second question, in SMA we're doing STEAM project, we're given STEAM project for the student, and in the beginning we filter the student's idea, and some ideas we actually rejected because it's too simple. Our reason is too simple, and most of the project we reject and ask them to make innovation because it is the existing product. They want to make the existing product. What do you think, sir? Whether if the group makes something that exists, is it still STEAM or not? Or what's your suggestion to respond this kind of group who that give the idea that they want to make the existing project? Thank you.
So really, you probably know my answer already. I would just say it doesn't matter. It doesn't matter. As long as the students get the experiences, the learning will happen. But to give you a better answer, yes, you can call it STEAM, even if you don't include all the element in one project. Why? Because across school, across grade level, the students will have done integration in all that. So when we say the school is doing a STEAM approach, it's not just that one single project, it's probably across grade level, across years. So yes, you don't have to include all the 6 or 5 or whatever subject. It's not really necessary. It's good if you can, but obviously it's not possible all the time, so it's not necessary. Secondly, is it okay to reject the ideas? I think it's okay, but even better if you can help them see interesting things in their simple idea. They may come to you with a very simple idea, but as a supervisor, a supervising teacher, if you can help them now see the subtleties of the interesting bits in a simple idea, that will help them propel their simple project into something more worthwhile. So I think that is probably the quality that you want. Not so much to reject an idea, but to help them improve. But I think more importantly, to see complexity in a simple idea. I suppose that's where you get the best or the most interesting project. Something so simple, but no one ever thought of it. To be able to see complexity in something so simple. So if we can do that as a supervising teacher, that's probably something good to say about us. Yeah? But thank you very much.
Oke, terima kasih untuk pertanyaannya. Sekali lagi kita beri tepuk tangan untuk kita semua. Baik Bapak Ibu, sesi kita sudah selesai. Masih banyak sekali yang perlu kita pelajari dan kita laksanakan untuk menyajikan pembelajaran yang bisa mengintegrasikan